If you use common applications that display maps or web pages, then you've probably used gestures like swiping to scroll a view, or pinching and unpinching your thumb and index finger to zoom in or zoom out. In this lesson, I'll start by discussing motion events. Android uses this class to represent the movement in various input devices, things like a mouse, a trackball, and most common of all, your finger. Next, I'll discuss how Android takes these motion events and delivers them to views and other objects so that your application can respond to them. And finally, I'll finish up with a discussion of how Android recognizes complex movement patterns or gestures, things like the pinch to zoom that I mentioned earlier. Android uses the motion event class to represent movements in an input device, such as a pen, a trackball, a mouse, or your finger. An individual movement event contains several pieces of information. It has an action code, which indicates the kind of motion that has occurred. It also contains a variety of data associated with that motion. For instance, it has information about the time at which the event occurred, which device the event came from, the event's location, and if appropriate, how hard the device was pressed, and more. And as I just said, this information will vary depending on the kind of input device involved. In the rest of this lesson, I'll focus particularly on finger touch events that are read by pressing a touchscreen. Many touchscreen devices today are multi-touch devices. That means that they can register and track multiple touches all at the same time. In Android, multi-touch devices emit one movement trace per touch source, and each of these touch sources is referred to as a pointer. When Android encounters a new pointer, it generates a unique ID that will remain constant for as long as that pointer is active. In some cases, Android will group multiple pointers within a single motion event. And in that case, each pointer within the motion event can be accessed by its index. But be aware that that index is not the same as the pointer's ID. The pointer ID is constant for as long as the pointer is active. The index in which a pointer's data is stored, however, may not be. So let's talk about motion events in more detail. Now, as I said earlier, motion events have an action code. When a gesture begins, motion events will be created, and they will contain some of the following action codes. Action down, which indicates that a first finger has started touching the screen. Action pointer down. That means that we've already had an action down, and now we have another finger that has started touching the screen. Action pointer up. We've had an action pointer and an action pointer down, and now one of the fingers has stopped touching the screen. Action move. Some of the fingers that are touching the screen have changed their position. Action up. The last of the fingers that was touching the screen has now stopped touching it. And action cancel. Something has prematurely canceled the current gesture. While a gesture is playing out, Android will try to ensure that its motion events obey the following rules. Touches will go down one at a time. They will move as a group, so a single motion event can refer to multiple pointers, and they will come up one at a time or be canceled. When you need to process motion events, you can use some of the following methods. Get action masked, which returns the action code associated with the motion event. Get action index, which returns the index of the pointer associated with this action code. For example, if the action code is action pointer down, then you can use this method to find the index of the particular pointer that is just touched down. Get pointer ID. Given an index, this method returns the stable ID of the pointer associated with that index. Get pointer count, which returns the number of pointers associated with the motion event. Get x and get y, which return the x and y coordinates of the pointer stored at the current index. And find pointer index, which returns the index associated with the given pointer ID. When a touch occurs on a view, Android generates a motion event and then attempts to deliver that event to various objects, one of which is the view itself. Android delivers the motion event through the onTouchEvent method. This method can process the motion event and should end by returning true if the motion event has been consumed and false if it has not. Objects interested in receiving motion events that occur on a given view can register to receive those events by implementing the view's onTouchListener interface and by registering the object with the view.setOnTouchListener method. The listener's onTouch method will then be called when an event such as pressing, releasing, or dragging occurs. And this method will be called before the touched view gets a chance to handle that touch. And again, onTouch should return true if it consumes the motion event, or false if it doesn't. In the simplest case, you can process each touch event independently. But applications often need or want to process multiple touches that are part of a more complex gesture. To do this, your code will need to identify and process particular combinations of touches. For example, a double touch will involve an action down, and then an action up, and then another action down, and finally an action up, all in quick succession. To give some examples, suppose you start a gesture by placing one finger down on the screen. That will generate an action down event and might assign a pointer ID of 0 for that pointer. If you keep that finger down and move it on the screen, you might get several action move events associated with pointer ID 0. Suppose now that you put a second finger down. In that case, you'll get an action pointer down event, and this new pointer might get an ID, say, of 1. If you keep those fingers down and you move them, you might then get several action move events associated with the pointer IDs 0 and 1. And if you now lift the first finger, then you'll get an action pointer up event associated with pointer 0. And then, if you finally lift the last finger, you'll get an action up event associated with pointer ID 1. In the next example, we'll start as before, putting down the first finger, moving it, putting down a second finger, and then moving those fingers again. But this time, however, we'll lift the second finger first. In this case, we get an action pointer up action associated with pointer ID 1. And then finally, when we lift the last finger, we get the action up action associated with the pointer ID 0. And for a last example, we'll use 3 fingers. We'll put down the first finger, then the second, and then a third. And then we'll move the fingers, and then we'll lift them up. First lifting the second finger, then the first finger, and then finally lifting the third finger. Our first example application in this lesson is called Touch Indicate Touch Location. This application draws a circle wherever the user touches the screen. The circle's color is randomly selected, and the application also then redraws the circle following the user's finger if it moves across the screen. And finally, when the user touches the screen in multiple locations, the size of the circles that are drawn will change to reflect the number of currently active touches. Let's take a look at this application in action. So here's my device. And now I'll start up the Touch Indicate Touch Location application. And when it starts, the screen is blank because I'm not touching the screen right now. Now I'll place one finger on the screen. And that causes a single circle to be drawn at the place where I've touched the screen. As I slide my finger along the screen, you can see that the circle is redrawn to track my finger movements. Now I'll place a second finger on the screen. And that causes a second circle to be drawn under that finger. And as you can see, the size of the two circles is now about half of what you saw when there was only a single circle. Now here I'll take away the second finger, and the first circle goes back to its original size. Now I'll put the second finger back, and again the two circles appear at half size. And I can drag these two fingers around the screen, and the circles will follow my movements. And finally, here I'll put down more fingers. 4, 6, 8, 10. I'm out of fingers now. So now I'll move them around, and now I'll start to take away some fingers. 8, 6, 4, 2, 1. Now let's take a look at the source code for this application. Here's the application open in the IDE. Now I'll open the main activity. And this code first creates a pool of custom views called marker views. Marker views will be used to mark the location of a single touch. Next, the code defines a set that holds the marker views that are currently visible on the display. And now down in onCreate, the code gets the frame layout that represents the main view of this activity. And then it creates an OnTouch listener and sets this as the recipient of that listener's OnTouch callback. Let's look at that method. When the user touches the screen, this listener's OnTouch method is called. And that method begins by checking the action code for the new motion event. If the action code is action down or action pointer down, then there's been a new touch. So the code creates and displays a new marker view. The code does this by recording the pointer ID and pointer index for this event. It then takes a marker view from the inactive list, and it then adds that marker view to the active set using its pointer ID as the key for this view. Next, it sets the location for this marker view, and then it updates the total number of touches for each currently visible marker view. And then it adds the marker view to the activity's main view. Now, if instead the action code was action up or action pointer up, then that means that a finger has been lifted off the screen. So the code essentially undoes what we just finished talking about. Now, as before, the code begins by recording the pointer ID and pointer index for this event. It then removes the marker view that was associated with the finger that was just lifted from the active set. It then adds that marker view back to the inactive list, and next it updates the total number of touches for each currently visible marker view. And then it removes the marker view from the activity's main view. And lastly, if the action code is action move, then the code adjusts the location of the affected marker views and initiates their redrawing. The code does this by looping over the pointers in the motion event. For each one, It gets the marker view for that pointer, and then it checks whether the pointer has traveled some minimum distance. If so, it sets a new location for that marker view, and then calls invalidate on the marker view, which indicates that the marker view wants to be redrawn.